Hi there, 7th graders. Thanks for checking in on Schoology to see what you missed during the 1-2A class, where you missed it because of MCA testing. So one of the things that you would have done if you had been in the classroom would have been the Gregor-Mendel challenge, and this we would have had you do in groups. And so if you look on Schoology, you can find this blank one where you should be trying it at home on your own first. And then you can watch, the rest of the screencast to see how to actually complete the challenge. So right now I would recommend pausing the screencast and then coming back to check for your answers. All right, well, hopefully you gave it a try on your own, and here is how you can accomplish the challenge. So I'm going to read from the beginning. It says, now that you've learned how useful a Punnett square is for determining the phenotypic and genotypic percentages for a cross, let's apply the Punnett square to Gregor-Mendel's experiment. If Mendel were to cross the F2 plants with each other to produce an F3 generation, what phenotypic and genotypic outcomes and their percentages are possible? So this is taking things a step further. In class and in the textbook, we've read only up through the F2 generation. We're asking for you to try what would happen with the next generation, what would be possible. And so to do that, we're going to use the trait of seed color, and yellow seeds are dominant, and I see the capital letters, that's how I know, over green seeds, so that's recessive. Now to get started, there is a hint, and basically the hint says that you might need to go back all the way to the F1 generation and do your Punnett square crosses to get to the F2 so you remember what the genotype was for those F2 babies. So I'm going to show you that right now, just very quickly. I'm going to flip this page over. So if we're going to use the letter Y for yellow, yellow being dominant seeds, it always starts out where they are true breeding. Okay, so we've got one homozygous dominant parent mating with a homozygous recessive. And when that's done, all the babies are now heterozygous. They have one of each version of the trait. So these are those F1 babies. So now I'm going to cross two of those and get my F2s. So to do that, I'm crossing two heterozygous. And here's what I get. So now everything in the boxes, those are my F2 babies. Now this is as far as we got in class. So now we're basically asking that you take these genotypes and think of all the different possible crosses you can come up with and work that problem out. So now I'm going to flip this back over, and we're going to do that in this space right here. Okay? So to get started, if I think back to, those F2 babies, well, if I look, looks like I've got, homozygous dominant. I could cross with a heterozygous. So I'm going to do that right now. And I'm actually just going to set up all of my possible crosses. I could also cross a homozygous dominant with a homozygous recessive. And I could also cross a homozygous dominant with another homozygous dominant. Now this is where kids always get a little stuck because they look back and they say, I only see one square of homozygous dominant, there's only one baby. But remember, this is theoretical, this is pretend. It doesn't mean that every time you cross two pea plants you only get 4 pea plants. This is showing us probability or percent. Really, Gregor-Mendel did this experiment with thousands of pea plants, and so if he had done that, he would have had many homozygous dominant pea plants to cross with each other. So that's what this one's going to represent here. So now I've kind of considered what I can cross with all of my homozygous dominants. Now I'm going to start thinking about homozygous recessives. What can I cross with that? Well, I've already done the homozygous recessive homozygous dominant cross here, but I haven't done homozygous recessive heterozygous yet. And then finally, I could do a homozygous recessive with another homozygous recessive, again for the same reasons that I explained here with this square. Okay, now there's one more that we haven't tried yet. I don't have a heterozygous mating with another heterozygous. I don't have that anywhere yet. So you should have a total of 6 Punnett squares that you now need to cross. So I'm going to do that very quickly right now. Oops, capital. These are all little. Okay, one more to go. All right, so now that I've done all of my crosses, the follow-up question says, now, what are the genotypic possibilities and what are their percentages? So here, I need to look at all the different letter combinations because that's what genotype is. So I'm actually going to take a different color pen so that I can keep track of things as I kind of cross them off. So I see one genotype is homozygous dominant, so I'm going to write that down here, but I need to know how many there are in order to calculate percent. So I'm going to go through and just cross them off and count as I go. 1, 2, 3, 4, 5, 6, 7. So it happens 7 times, and I've got 4 boxes in each one, and there's 6 total Punnett squares. 4 times 6 is 24. So 7 out of 24 would be homozygous dominant. And if I do the math, that is about 30%. Okay? Then I'm now going to go through, I see I've got heterozygous that I can do. So I'm going to count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 24. That's about 42%. And actually, this number here is closer to 29%. So we're going to go with that. And then my last genotype that I have is homozygous recessive. 1, 2, 3, 4, 5, 6, 7. So 7 out of 24. Now just to make sure I did everything right, 7 plus 7 plus 10 does equal 24, so I've accounted for all of my squares. And 7 out of 24 is 29%. So we've got, again, I mean, I'm rounding, it's not exactly exactly the percent or correct amount, but it's very, very close. It gets us the right idea. And then finally, now what are the phenotypic possibilities? So that's the physical appearance. So I want to know how many will actually have yellow seeds. Well, if I look here, these 2 genotypes, because they have at least one dominant trait, will allow for the yellow seed to show up. So that's 71%. I just added 29 and 42. So 71% will have yellow seeds. And then over here, this is the only genotype, 2 recessives, that will allow for green, and that's 29%. So now I've completed the Gregor-Mendel challenge, and hopefully you were able to do as well. If you couldn't, hopefully you could at least follow along and that most of this made sense. Thanks for giving it a shot.